we're in section 4.3. We're going to do example 2 now. And I found this one kind of curious, so I want to kind of talk to you guys a little bit about it, see if we're thinking the same thing. Remember, this is given information. That you need to pay attention to that. Make no assumptions about your figure unless you're given some sort of congruency figure. This helpful hint was really good when I just looked at it. It says when you write a statement such as triangle ABC is congruent to triangle DEF, you are also stating which parts are congruent. So those congruency statements tell you a lot. And I'm going to go back to my highlighter again, and I want to just point out to you, I'm going to put like a little dot under how they line up. So that tells me if triangle EFH is congruent to triangle GFH, E and G are congruent. They are equal in size, okay? Now let me switch to the yellow, and I'll put F is yellow, okay? So this one here and this one here, they're going to be equal in size, okay? And then I'll switch to this lighter green color, so we've got H and H, and so these two angles have to be equal to each other as well, and I'll try and do the little box there. So if one of them is 90 degrees, which is what's being indicated here on this right side, then the left side also has to be 90 degrees. Now in step 1, they wanted you to find the value of x. I mean, I guess you could do that. I'm not sure that that's necessary, but I'll try and explain to you why I think that's unnecessary. But this is how you would find x. You would go, okay, well, I know that, angle H here is congruent to this angle H as well. And so you could go, well, 6x minus 12 is equal to 90. Okay, so you could do that, add 12, and then divide by 6, and you've got 102 divided by 6, and I believe x is it 17? Yeah. So yeah, you could find that, and then to find the measure of GFH. GFH is right here, and that's equal to this angle here. So anyway, it's kind of, I just think they really kind of did it the long ways around as your book was explaining it to you, because what you just figured out is that this is actually 90 degrees. It's a right angle. Now that reason why it has to be a right angle is this forms a linear pair. If one of your angles is 90 degrees, then the other one has to be 90 degrees, because 90 plus 90 is the 180, which is your straight line. So that's why I didn't really feel like you needed the x necessarily, because we already know what that is. So we have enough information about this triangle right here. We could find this missing angle up here, and that would mean that we would have the measurement over here. So we could actually use the triangle sum theorem. I think that would be a little bit faster way. Do 90 plus 21.6 plus x is equal to 180. Add those up. What do we get? 111.6 plus x is equal to 180. And then subtract 111.6 from each side. And we're going to get x is equal to, if you have your calculator, it'll be a little bit faster if you do that, 68.4 degrees. And so that's what the measure of angle GFH would be equal to, is 68.4 degrees. Because if we find this one, then we automatically know what that one is right here, because they're congruent. So anyway, I think it's a little bit kind of around a roundabout way to get to that answer. I didn't really like that first part. I think the first part, letter A, was unnecessary, that you really did have enough information from the drawing and your understanding of linear pairs that you could have jumped in there and figured it out on your own. All right, now check it out. We've got 2 of them to try here and here, so I'll give a +2, 1 for each that you attempt. And let's get those right. And if you have any questions, let's bring them to class tomorrow.